When you drop an ice cube in water, it floats. But why? Well, you probably know that an object of higher density sinks in an object of lower density. But ice doesn't sink in water. So what's going on here? Surely ice, as a solid, should be the denser material, right? Well, the common conception is hotter materials are less dense as hotter particles have a greater kinetic energy and thus have a greater tendency to bounce off each other and spread out. And this is true almost all of the time, except for water. And the reason why is all down to water's molecular structure, H2O, 2 hydrogens and 1 oxygen all bonded together with covalent bonds, essentially a shared pair of electrons holding the atoms together, with 1 electron in each bond coming from the hydrogen and 1 from the oxygen. Now, oxygen has 6 electrons to give. 2 are in the covalent bonds with the hydrogen, and the 4 remaining group together as 2 lone pairs, which, due to the negative charge on an electron, are very concentrated areas of negative charge. On top of all this, oxygen has a higher electronegativity than hydrogen, which essentially means it attracts the electrons in the covalent bond way more than the hydrogen does. And since the hydrogen used to have a neutral charge, but its negative electrons have been lost to the oxygen, it's left with a positive charge. So now we're left with a bunch of positive and negative charges, and you might expect them to want to attract. The problem is, when water is fairly warm and in its liquid state, the H2O particles have lots of energy and move about so fast that these attractive forces have little effect. But as the water cools down, these attractive forces, known as hydrogen bonding, cause the water molecules to tend towards a regular lattice shape. This structure, also known as ice, is less dense than liquid water, and that is why ice floats in water.